get some important definitions. Okay, what is a polynomial function? And another important definition we're going to look at is a leading coefficient. And a leading coefficient is just the number in front of the highest power. In a polynomial function, you're going to have x's, and the exponents are going to be nice numbers. Whole numbers, positive whole numbers. Polynomial functions won't have decimals up there, won't have fractions, won't have negative numbers. And one of the things that I'm going to get you to write right beside these, okay, so we are going to look at and define things as either odd functions or even functions. And odd functions are when the highest exponent is odd. Nicely defined. Boy, it would really mess you up if they decided we're going to call the odd functions where the highest exponent is even, and the even functions where the highest exponent is odd. Just a mess. No. An odd function is when the highest exponent is odd. And the first thing that's going to help us graph is something called end behavior. And we're going to say that if you have an odd function, the end behavior acts like a line. You know lines either go up or they go down, and the end behavior is where the arrowheads are going to be. So odd functions will either start down here and end up here, or start up here and end down there. They're going to act the same way lines do, but they'll have extra stuff in the middle. But when we talk about end behavior, we're just talking about where things end. Even functions again, that's where the highest exponent is even. Their end behavior acts like a parabola. So you had parabolas that were opening up, and you have parabolas that open down. So anytime you have an x to the 4, or an x to the 6, or an x to the 8 graph, your end behavior is going to look like this. So if we go back quickly to the ones that we just matched, you can see that this happens. For graph number 1, graph number 1 was your x cubed graph. That's an odd function, because the highest exponent's an odd number, and its end behavior started down there and ended up there, just like a line would. For the other odd one, x to the 5, its end behavior is here and here, and it acts just like a line that was going down. And the key to seeing which way it's going to be, which line is it going to be, is all based on the leading coefficient. For the x cubed graph, its leading coefficient was positive, so you think of a positive line. For the x to the 5, its leading coefficient is negative, so you think of a line with a negative slope. It would be going down. Its end behavior is that way. For the x to the 4 graph, in number 3 here, its end behavior is like this. That's because it's an even function. End behavior is like a parabola. And since the leading coefficient is positive, we think of a positive parabola. If the leading coefficient is negative, we think of a negative parabola, and sure enough, that's where that graph ended. So if we knew this idea about end behavior, this matching would have been even faster for us. And that's what they have summarized on the next page. They're like, here's a line. Here's a positive line with its end behavior. Here's a negative line with its end behavior. It's an odd function. It's going to act like a line. Obviously, a line should act like a line. Just like a parabola should act like a parabola. A parabola is an even function. Here it is a positive leading coefficient, so its end behavior acts like a parabola, because it is a parabola. And here the leading coefficient is negative. So these ones we knew already. But now as we go to the new ones, oh, I have an x cubed graph. It's going to act like a line, and because the leading coefficient is positive, I think of a positive line, and sure enough, that's where my arrowheads are on my x cubed graph. There's just extra stuff in the middle. We're going to worry about that extra stuff in the middle later, but right now, we're just worried about the end behavior. Same thing with a negative x cubed graph. We think of a line. There's my end behavior, and sure enough, that's where the arrowheads act or end up on that negative x cubed graph. X to the 4 graph, if it's positive, I think of a parabola. There's my end behavior, and sure enough, that's where the arrowheads are on that x to the 4. For the negative x to the 4, negative leading coefficient, that's my end behavior, and sure enough, that's where the arrowheads are there. And finally, an x to the 5 is odd, so it's going to act like a line. And sure enough, the arrowheads all match up for that idea. So our job is to try to graph these as best as possible. And we're going to start off, well, okay, first of all, we're going to look at what the textbook describes it as. And I hope what I'm going to get you to do is, I think our definition is way easier to remember. Our definition for end behavior is just based on lines and parabolas. So if you have an odd number and it's positive, you would draw a line with a positive slope, and there's your end behavior. I think that that is a lot easier to remember than this. As x goes to negative infinity, the graph falls to the left, and as x goes to infinity, the graph rises to the right. If you had to memorize that, you'd be like, oh, this is a much quicker definition for you. And you can like see it, it's a picture, boom, you know where your arrowheads need to be right away. Same thing, if it's negative, this is way easier to remember the end behavior than this. And same thing with the even ones. If it's positive, that picture tells you exactly what you need to do. If it's negative, that picture tells you exactly what you need to do. Way better than those definitions. So I'm never going to ask you to write out those things. You're just going to have to apply it. So if you remember that odd ones act like lines, even ones act like parabolas, you're going to be set. So we can go to our first example. Oh, yeah, let's go to our first example. Sketch each of these graphs. So the first thing, the only thing that we have so far is, as a strategy, is our end behavior. And our end behavior of this one, it is odd because the highest power is a 3. And in front of the x cubed is a positive 1. So you would know this as your end behavior. Now, anytime you want to graph something, you can always go back to a skill you learned way back in grade 9. You can make a table of values, and the more points you have, the more accurate your graph is going to be. Table of values is an awesome strategy. The problem with this is that it is annoying and it takes a long time because you have to like find a whole bunch of points. So you're like, okay, what happens if I plug in 0? If I plug in 0 for x, then y is 0. 1 point. Do I know what the graph looks like yet? No. So I should find another point. So you plug in 1. 1 minus 3, negative 2. And then plug in another point, 2, and this will be 8 minus 12, negative 4. Plug in 3, we would get 27 minus 27, 0. So you would know that, okay, in between these, oh, I want blue, there we go. In between these I have this shape, and so far I know that my graph needs to end up here and down here, so I get a sense of where it's going, but I'd probably have to figure out some more points. So the more points you plug in, like if you plugged in negative 1 now, you're going to get negative 1 minus 3, you're going to get negative 4. It's going to give us okay, so it seems to be like this now. It might make sense that this is the shape of our graph. We know it's end behavior, and we did a bunch of points, and we got an idea of what the graph looked like. We could do the same thing for part B, but right now all I want you to do for part B is think about the end behavior. It is an even function and negative. So you would know that it looks like that in the end. To find out what happens in the middle, you would have to do a lot of values with the table of values. Okay? And of course, what we're going to do today is we're going to learn better strategies for graphing it other than table of values. However, whenever you're stuck or whenever you want to know more information about a graph, table of values is a super powerful thing. You can always find more information. It's just a little bit annoying because it takes so much time. So the questions I'm going to get you to circle for this one are 5, 6, and 8.